All right. Okay, so first, I just handed back your Chapter 4 calculator portion of the test. And that is going to be, you can recover, for those of you who are interested wanting to recover your test grade up to 79, we can do that next week. So next week, come in any morning or fourth period to do corrections on the Chapter 4 calculator test. And then the recovery date is next Friday, okay, next Friday, March 4th. There's no assessments next week, so, but this week just wanted you guys to focus on getting ready for the Chapter 5 and 6 test. I'm also going to be having help sessions. So this afternoon, 3:40, tomorrow morning, 7:30, and Friday morning, 7:15. I'll have help sessions going over various topics, and I'll talk about those topics now. So, oh, and then on my website, I'll include them over here. So you see those test help sessions dated. I will record it, and then I will make this a link so that you can watch the videos if you want to watch those the videos that I'm going to record. On my website, under our current unit, under February 25th, I also have the test topics here. So let me go over briefly those test topics. So number one, make sure that we know the solid differential equation. We'll be doing that pretty much. We're focusing a lot on that, and we'll do some more today. General equation, right? Separate the variables, take the antiderivative, get to that plus c or times c, and then we can move to the particular equation, which is taking the order pair and updating that general to a specific once you solve for that c value. Tangent line and linear approximation are very much kind of attached to number one. So tangent equation is where you get the order pair, you get the slope from the differential equation, right? Your slope is going to come from the differential equation, because differential equation is just a fancy word for slope formula or your derivative. And then once you have your tangent equation, then you can use that to do linear approximation. Because linear approximation, you're just taking whatever decimal that they provide and insert it into the tangent equation, and that's your linear approximation, right? And it's in the name. We're using a line to approximate a value, right? So we're using a tangent line to approximate a value. Creating a slope field. We did that some yesterday, where I give you a blank or give you dots on empty order coordinate plane. You identify a point, plug into the differential equation, get a number in return, and you translate that number into a slope expression, and then just do a short line segment through that point. Okay. Number 6, matching slope field. We'll probably do some of this tomorrow. This is where we had a filled out slope field, and we had to match with the appropriate differential equation, right? So I'll focus on that tomorrow. Y equals c to the kt word problem. We focused on that yesterday, where your y prime equals ky is the starting differential equation, but we're not really spending a lot of time taking the antiderivative or solving that differential equation, because we know it's just going to turn into this y equals c to the kt. So we make that jump, and then we take the order pairs or the information provided, create order pairs out of them, and then get to the c value, get to the k value, and then use your calculator to make further estimations. Inverse trig integrals. This is the last topic that we covered for this unit. And sometimes we got to complete the square. We have to involve inverse trig integrals. Okay. And then also, you guys just received back your 5.2, 5.5 quiz. And those topics are also on the test. So taking the antiderivative involving exponential function, base e, natural log integrals, use substitution, synthetic division, and trig integrals involving natural log. Okay, you'll get to use your calculator, so make sure you bring your calculators on Friday. Yes, question?
If you do on the quiz, you would do to state the k value that makes the following true?
Yeah, sure. Let me see here. So I know there's different versions out there, but let's say the problem was this one here. So basically my hint was don't even look at the right side. Just solve this problem like you normally would, right? So you target the exponents. Make your substitutions. And then you just push out all the coefficients out in front. So in this case, it's 6 over -3. You know that -2 is going to stay, so -2 e to the u plus c. And then replace the u back in terms of x. And at the very end, whatever is sitting in front of the eval, the exponential function, that's your k value. Okay, we're also going to be responsible for memorizing derivative and derivative and integral formulas. So if you guys go to page 12 of your packet, and let me just highlight those rules, as well as the ones that we don't have to worry about. Okay, so page 12 in your review packet. Everybody get the review packet from yesterday? No. Anybody else missing the packet? Okay, so let me just go through the rules that you'll need to memorize. Power rule, we've been using that ever since the beginning of first semester, so make sure we know that. Trig derivatives, right? Keep reminding us just to put this at the top of the page, because if you have these trig derivatives, then you also know your trig integrals, at least the original 6, right? E to the u, we know that derivative rule. It's just the function itself times the exponent's derivative. Natural log of u is u prime over u. You can cross off these. I'll put this on the test. The a to the u exponential function, a to the u, and the log base a. Okay. Right, moving on to the integral rules. Power rule for antiderivatives. Trig integrals. Okay. I hope that you guys aren't spending the time to memorize these, right? Because I don't have these memorized. Okay. I go through these. Right? I know my trig derivatives, and I'm just reading my derivatives backwards to get to my integral rules. Right. So I don't want you guys to feel like you have to memorize a whole new set of rules when they're already staring back at you from the trig derivatives. Okay. These next 3 rules, these are rules that we recently learned in chapter 5, right? 1 over u is natural log, e to the u is e to the u, a to the u is a to the u with a little bit of extra coefficient that's part of the process. Okay, make sure we know those. Trig integrals, these are the 4 trig integrals that are not part of the original 6 that involve natural log. All right, you saw that on the quiz, so we need to make sure we continue to know those. And then the final rules that we learned are these arc trig integral rules, right? So these rules are coming from the arc trig derivatives, which you can cross out. You're not going to have to be responsible for those. But there's only 3 of them, right? If there's no square root in the denominator, you know it's arctangent. The square roots are arc sine and arc secant. The best way to tell is look at what's first. If the constant is first and positive, that's arc sine. If the variable inside the square root is positive in first, that's indication you're dealing with arc secant.
So you have to know the arc trig derivatives?
Yeah, don't have to know the arc trig derivatives. No, not for this test. Okay, so spend the next few days or next 2 days looking over this, right? And spend the time to make sure you know these. We've been building these up ever since the beginning of the school year, so hopefully some of these will come easier because you've seen them for a couple units now. We do have a couple new ones, so we're just going to add that to our list of ones that we know. Okay. Any questions? All right. In your packet, let's go to page 3. I think we just did 2C, right? I don't think we got to 2D, so let's do a recap of 2C. So on page 3, we solved the differential equation, right? We cross multiplied. We separate the variables. Left side was natural log, right side was power rule. Okay. We got the left side all cleaned up. Right side, we had to separate them into individual parts. And then we dropped the absolute value. We solve for y with the c still there, and we call that the general solution or general equation. Okay, so from there, we take the order pair that was 0, 3. We insert it in for the x and y, and we solve for c, and we solve for c. Once we solve for c, we updated the general to specific, and all we're doing is changing the c value to a number. Okay, did we get done with this part yesterday? Okay, so now let's try part D. So part D is create the tangent line equation and then do linear approximation. Okay, so part D, find the equation of the tangent line at x equals 0. So anytime you're looking for a tangent line equation, you need what and what? Yeah, order pair and slope, right? So order pair, I think is provided for you from part C, right? Order pair 0, 3. And how do we get to the slope? Yeah, good, differential equation, right? Your differential equation is your slope equation, right? Insert 0 in for x, 3 in for y. What is that going to turn into? Just what? 0, right? Okay, so let's build our tangent line equation. Order pair 0, 3, slope 0, point slope form. So normally the slope is not 0, right? So normally the equation has a bit more to it, but here, because the slope is 0, it kind of wipes everything out, and we're just left with y equals 3. Right, but this seems a little bit strange, right? Just because slope is 0, that's why it wipes out the right side, and it feels more simplistic than other tangent line equations. So now part D, linear approximation, is where we insert the decimal into the x value. Now normally it will be more than what we're seeing here, but because the slope is 0, it doesn't matter what we plug in for my decimal. It'll still be just y equals 3. So, but this is our normal process, right? Normal process, we take our tangent line equation, we look at the x value, and we insert that decimal into that x value. All right, any questions on this problem? Okay, let's turn to page 4 and let's focus on the bottom half. Let's go over some of the integral, okay, let's go over the integral problems that we more recently learned. Okay, so page 4. Okay, we'll do this problem a little bit later, but let's go to the middle half and let's try number 4 here. Okay, so we look at number 4 and we go through our process. We can't expand, right? Too many terms in the denominator. If we go through u substitution, if we think of the u value as the 1 minus x to the 6th, that's not going to be a good match either, right? That degree is too high. The derivative will be 6x to the 5th power, and there's that sizable gap here. So anytime we see that sort of a gap where the denominator variable is higher than the numerator by more than 2 or by 2 or more degrees, that gap is indicating that we need to involve arc trig. Arc trig will allow a little bit of this to shrink because we're going to be able to adjust that denominator variable. So we know this is going to be involving an arc trig rule. We see the square root, so we know it can't be arctangent. It has to be either arc sine or arc secant. And also we pay attention to that first term, right? That first term is a constant. That's the a value. So we know most likely it'll be the arc sine, right? Arc sine is a better fit than the arc secant because my first term inside the square root is the constant. Okay, but once you identify that you're going to be targeting an arc trig rule, our next step is trying to get the denominator to show us the u and a value, because a lot of times the a and u value is not easy to spot with this current form. So to allow for that denominator to be in a better form, we're going to create this template. We're going to create parentheses squared, because we know that if we can get this into this form without changing the overall value, we're able to see the a and u value a lot more clearly. So what can I put inside the parentheses and not change the overall value? One, right? Yeah, 1 squared is the same thing as 1, so I haven't changed anything, but it's just good to build that, that denominator form. Now, what can I put inside the second set of parentheses so that when I square it, I'm not changing the overall value? That's cute. Let's check that. Anytime exponents are next to each other, we're going to multiply. So 3 times 2 is 6. Yeah. Okay, so now we can pick our a value. Remember, your a value is the constant, your u value is the variable, and you're just going to look what's inside the parentheses, okay? If you include the exponent outside the parentheses, then you've kind of undone the progress that we made, right? We don't want to go after the exponent outside. It's so that we can get the form appropriately. Okay, so now our a value is 1, our u value is x cubed. We're going to go through a little bit of u substitution to get that dx to be replaced, and also we need this x squared to go away, right? This x squared is not suitable for the arc sine rule that we're trying to match up with, but we'll see what happens. Okay, du dx. And cross multiply. And now let's make our substitutions. X squared goes away. That's a good sign. But we do need to keep track of what? Yeah, there's a 3 in the denominator that pushes out as 1/3. So now, if you look at this compared to the rule, this should match perfectly, right? Assuming that if you can cover up that 1/3, matches perfectly with the arc sine rule that we're about to apply. Okay, now that we have a perfect match, we can jump into the arc sine rule. Arc sine is the only rule that doesn't have a 1/a in front. Okay, 1/a is, there's one for arctangent, there's one for arcsecant, but arc sine just jumps directly into it. There's no 1/a. But there is that 1/3, so that 1/3 is not part of the formula, but it is a coefficient, so it needs to stay in our answer. Okay, the rule says u/a, so x cubed over 1. Okay, you can drop the 1 if you like, but they're the same thing. Okay, any questions with 4? Yep.
Not before, but on the test, is there going to be like long division, not synthetic division?
I think I'm just going to do synthetic division on the test. Yeah, so I won't do long division on the test. Okay. But there are certain scenarios for synthetic division that we haven't done yet, so we'll do those tomorrow. We'll do synthetic division practice tomorrow. Okay, number 5. Okay, so let's take a look at number 5. We go down our checklist. Too many terms in the denominator. We're not going to be able to do power rule. We can't split up into individual fractions. And then we look at, okay, what about u substitution? Well, if we let the u value be the entire denominator, the derivative will produce 2x minus 6, and we don't have any x's up here to match with that degree. And you can see that the degree in the denominator is higher, but it's higher by more than 1. And that's the indication that, okay, there's that gap. We need to close that gap using our trig rule. So if we want to do our trig, it's going to have to be arctangent because there's no square roots, right? But if you see a trinomial, this is not quite set up for us to pull the a and u value. We need a binomial square to show up. So we do need an intermediate step to get this denominator to be in the form that is better suited for pulling the a and u value. So what's that intermediate step that we need to involve? Yeah, good. Complete the square, right? Factor and complete the square. Okay, complete the square. It doesn't solve the problem, but it will get the denominator to look more like what we would to make it helpful, more helpful for us to go to our next step. Okay, so we're going to step to the side and we're just going to focus on that trinomial in the denominator, and we're going to set it up to factor nicely for us. Okay, you're always going to insert spaces. The first space is going to come after the first 2 terms, and the last space is going to come after the last term. The first will be positive, and the second will be negative. Now, what goes inside these spaces here? What's the formula?
Squared.
Yeah, so b over 2 squared. Yeah, so we got to go through that formula there. What's our b value?
6.
Good. So you don't have to worry about the negative because everything is square, so we're guaranteed to get a positive out of this. 6 over 2 is 3 squared is, okay, so 9 goes in both spaces. Okay, good so far? Okay, the first 3 terms should factor nicely for us. 1 multiplies to be 9, adds up to be negative 6. Yeah, negative 3 and negative 3, right? And we know that we're expecting a duplicate binomial so that we can merge them together and make it x minus 3 squared. And then what is 14 minus 9? 5, okay. So we have a pathway towards getting that denominator cleaned up here. Okay, you can take less steps than me. I just want to kind of show every step along the way. The denominator is close, but I need 2 sets of parentheses in the denominator, right?
You have to push out the floor.
You don't have to. You don't have to. I just eventually it's going to get pushed out, but you can have it. Yeah, as long as you have it in the problem, it doesn't have to come out. No. Okay, x minus 3. That's already set, right? We already have that ready to go. How about the second set of parentheses? Good, root 5, right? I need root 5. I need that root 5 squared to make it match, and then I need this form so I can see my my a value a little bit more clearly. Okay, your a is always the constant. Your u is the variable. Sometimes the a and u can be flip-flop because there's a plus sign in between, so it doesn't matter which one comes first, but we should still be able to not get confused with the a and u value, right? The u always has the variable in it. Okay, we go through derivative. We know that this won't produce any coefficient, so it'll just be 1. Okay, let's make our substitutions here. I'm going to convert everything in terms of a and u, in terms of au and du, because I want my problem to look exactly like the rule that I want to use. There's no extra coefficient, just a -4. Okay, we look at the rule, matches perfectly. Now ready to jump into the rule, right? The coefficient -4 will have to stay in our answer, but then we have the 1 over a, the arctangent, and u over a plus c. Okay, 1 over a, there's my a value. Arctangent of u over a. Okay, this is perfectly fine. You can maybe, if you want to clean the coefficient up a little bit, you can leave radicals in the denominator, okay? No need to rationalize any denominator. Okay, any questions with number 5? Okay, take a look at number 6. Number 6 and 7 is more review for the quiz, more like the quiz topics there. Okay, if you take a look at number 6, this kind of has the feel of an a to the u rule, right? That 9 is basically an exponential function, 9 raised to an exponent. But if I want to target this a to the u rule, what needs to be adjusted? Yeah, the 9 needs to be up in the numerator, because if I want to use a to the u rule, I don't have a rule for a to the u in the denominator. I only have a rule for a to the u in the numerator. So I'm going to force that 9 to the top. If I move the 9, what has to change? Good. Exponent has to change to a negative, right? So this is a better starting point for our problem. Move that 9, change the exponent, and now I can more clearly see what you're targeting, right? You can target that exponent to be the u value, find a derivative, and you're hoping that this will go away once you go through your u substitution. Okay, try that. Okay, the u value is negative cosecant of 2x. we find the derivative. Remember, derivative is negative cosecant u, cotangent u times u prime. The two negatives will cancel out, leaving me with a positive. Make the substitution, and we should get the cosecant cotangent to go away, but we do have to keep track of the negative and the 2 in the denominator, so there's going to be a negative 1/2. That's going to have to be in the very front. Cleans up nicely to just be negative 1/2 in front, integral of 9 to the u. Now that matches nicely with our a to the u rule. A couple of things that I saw on the test that I want to make sure that we are careful about. Sorry, on the quiz. I know it feels like you can merge the negative 1/2 and 9 together, make it negative 9/2. But why can't we put those two things together? Yeah, it's raised, right. This 9 is not just a 9. That 9 is raised to the exponent. So we can't merge these until this exponent is resolved. And so that 9 is not a constant. So I see some students try to do like negative 9/2, or they try to cancel out, they try to merge those two. But those are not like terms. So we can't multiply coefficient with a base of an exponential function. Okay, and then the rest of the rule says 1 over natural log of a times a to the u plus c. Okay, my key is a little bit off. I think my key has a positive coefficient. It should be a negative coefficient. Yeah.
Like the du over, like, isn't that cosecant squared? 2x, or is it just cosecant?
Oh, you mean the derivative?
Yeah.
So the rule for cosecant of u is negative cosecant u cotangent u times u prime.
So it's not cosecant squared 2x, it's just cosecant squared. Like a part of the derivative.
Yeah.
The cosecant isn't squared.
Yeah, cosecant isn't squared. I think maybe you're thinking about cotangent. Cotangent derivative is negative cosecant squared. But the derivative for cosecant is cosecant cotangent. Okay, any questions with 6? Okay, try number 7. Now, number 7, there's a little bit of u substitution, right? What's the u value? X over 2. So anytime there's a trig function with a little bit of something inside the trig function, you got to keep in mind that there's always going to be a leftover coefficient out in front. I think I saw this on the last quiz where, remember the problem that I had like multiple trig functions all lined up together? And most of you guys did well just identifying all the appropriate integral rules. But I think one of them was like sine of 2x or cosine of 2x. And that 2x, we can't just ignore it. That 2x is going to produce a leftover because of use substitution. So there's a little bit of a shortcut that I want to kind of talk about, but you guys don't have to do the shortcut if you don't want to. The shortcut involves this 1/2 x. Right? What is that 1/2 x going to turn into after? What's the leftover that's going to come out of that 1/2 x? It's going to be a 2. Okay. Normally, if we go through a derivative chain rule, it'll be times u prime, but integral is the reciprocal of the derivative. So 1/2 comes out of it, but then the flip version of it is going to be the coefficient. So if you don't like to think about that shortcut rule, that's fine. You can go through the full u substitution and just convince yourself that that 1/2 x will eventually turn into a 2 that gets a part of the outside. But that is a possible, I think that's a shortcut that some of you guys may want to consider, just because if it's an easy linear function, you just, okay, derivative, flip it, and just jump to the next step. I don't have to go through a full u substitution if you're comfortable making that read. Okay, so then you're down to integral of secant of u, And secant u is the new rule involving that has the natural log involved. So natural log secant u plus tangent u plus c. And the 2 just tags along in front. And also, remember that when you do indefinite integral, that you have to bring your x variable back. So some of you guys can see on your quiz, some of you guys lost a point just because you didn't bring the original variable back. So use substitution as a temporary variable to help you through the process, but in the end, right, bring your original variable back into your answer. Okay, let's go to the top of the page and let's do just part A of that velocity problem. So page 4, top of the page, the V of t problem. Try that one. Okay, does anybody still need this? Now, if you're dealing with a differential equation and if it feels unfamiliar because you don't see x's and y's, just keep in mind that your anchor is the t, right? So you should be able to recognize the t and recognize, okay, if I see t, that's my x. Whatever strange variable you don't recognize, that's your y variable. So in this case, it's the v that's going to be your dependent. It's going to be the v, the dv that you're going to try to put on the left side. So. Right. So we start the process, right? Try to get fractions to show up, cross multiply. Okay. Hold on to those parentheses, right? We don't want to lose those parentheses. They factor the -2 out to help you group terms a little bit easier. So if you lose the parentheses, it kind of makes it a little bit messier. So I created my fraction, cross multiplied, dv on the left, dt on the right. I got the dv and dt's locked in. Those are in their right spots. But do we have everything in place? What's out of place here? Okay. But if I want to move the v, I have to move what along with it? Good. So the whole parentheses will go along with it. Okay. And where's it going to end up? Left. Good. Denominator. Okay. So you have to be comfortable with leaving a variable in the denominator. Okay. We have rules for them, so don't feel like you're doing something wrong if your variable lands in the denominator. No, we can't.
The -2.
Good. Yeah, -2 on the right side. So typically we say that we only want to move things to the left side that is absolutely necessary. Anything that does not be on the left side, leave it on the right side.
And you can drop the parentheses.
Yeah. So now you drop the parentheses because now there's nothing impacting it. But yeah, you can drop the parentheses now. Okay. So the left side. How do we approach the left side? Yeah, use substitution. There's not a whole lot of coefficient going on here, so it'll turn into a what? What rule are we going to eventually target?
1/u.
Yeah, 1/u du, right? Natural log. Okay, so natural log on the left side. How about the right side?
It's just going to be -2x.
Good, -2 t.
Sorry,
Yeah, but you got it. You're using power rule, and you're bringing the variable back into your right side, and then plus c, right? Okay. For the right side, yeah. Remember, both sides produces plus c, but we only group the plus c on the right side of the equation. Right. All right, good so far? Okay, so the calculus is done. Everything is up to the function level. Now we're just trying to get to the general solution. We're just trying to get to that V. So what can we do to both sides? Yeah, base E, let's get that natural log to go away on the left side, but we got to balance the equation. So break both sides with E as the base. Left side cleans up the right side. We split that C away from that first term. Careful, what is that plus C going to turn into? Good, times, good. Operation changes, right? That plus is going to turn to multiplication because we're bringing that exponent operation down to the base level. Okay, drop the absolute value, turn that E to the C to C. And now move the 16 over, and you have your general solution. So even if a problem doesn't ask you for the general solution, just always keep in mind that you're arriving at the general before you get to the specific, right? Okay, so now what can we do? Yeah, take what's the order pair that we're going to use? Good. 0 in for T, -50 in for V, and then you should be able to get make your way down to the C value. Okay, your C value should end up being -34. And now you're just taking their general solution and just replacing the C with -34, and that will turn it into a particular equation. Okay, questions here? Okay, I have one more for us. Let's go to page 5, number 2. Okay, page 5, number 2. Cross multiply. Y is on the left, X is on the right. Take the antiderivative. General solution, order pair, particular solution. Cross multiply, get the dy dx's in their right places. The x is out of place, divide it over to the right side. Okay, what rule can we use on the left side? Power rule, right side. Good, natural log, right? 1 over x, the first power is natural log. Okay. That will take you to the general solution. And then you can use the order pair to get that C value solved. Okay, C is 1. Update that C with the 1, and then you can graduate that general to a particular equation. Okay, any questions with part A? Okay, part B says state the domain, but let's sketch the graph first, right? You're given order pair 1, 1, so plot 1, 1 onto the graph, and the slope field is there to kind of help you kind of guide your graph a little bit, right? And the graph should also look like this natural log of absolute of x plus 1. So you know what the graph looks like, and the slope field kind of helps you create that graph. Okay, any questions with part A here? Okay, so let's get the graph to show before we find the domain. We know the graph has to go through 1, 1, so plot 1, 1 onto the graph. And then you see how the slope field kind of helps guide your graph a little bit. So I'm just going to follow the path. And here the left side is kind of getting really steep, but it's kind of getting closer towards the y-axis, but never reaching it. And also, this should be consistent with what we know about this graph, right? This is natural log of x shifted up 1 unit. So we should be able to look at this graph and determine the domain. What's the domain of this graph? Good. X values, right? The furthest left to furthest right. Furthest left is 0, furthest right is infinity. And double check your x value should be part of your domain, right? It should be, right? Good. All right, part C, find the equation of tangent lines. So if I want to find tangent line equation, what information do I need? Good, order pair and slope. Now I have the x value. How can I find the y value that's part of my order pair? Okay. I can't use the 1, 1, but is there something that I can use to find the y value? Okay, into the what though? Into A. Yep, good. This is our equation, right? We found the equation, and that equation is going to be helpful to find that y value. Okay, natural log of e is 1. Okay, so 1 plus 1 is 2. There's your order pair. Okay, how do I find the slope? Good, dy dx, that's my slope formula, right? My slope formula says 1 over x, my x is e, so 1 over e. Okay, we have everything that we need, point slope form. Let me just move that 2 over to the right side to get it ready for part D, which is the linear approximation part. Okay, how to do linear approximation? Good, into your tangent line equation, right? So you should feel like linear approximation is an easy process, right? If you have a tangent line equation in front of you, all you're doing is you're just substituting the x with the decimal that they give you. Plug that in. The rest, make the calculator find that decimal approximation for you.
If we double the 2 over to the other side of the equation.
That's fine. You don't have to move the 2 for a tangent line equation, but yeah, I just got it ready for part D. That's why I moved it over.
So if you put in 1 over e in the calculator, it'll do it as like
A decimal.
Find it.
Yeah, it'll find a decimal value. Yeah, 1 over e is like 1 over 2.7. It'll give you a decimal value.
That's how you did it.
Guys, something something quick I want to show you about the test. Did I talk about the dominoes problem? Okay, I forgot. So just real quick, for number 1 on your calculator portion, a lot of you guys wrote that the unit is still dominoes per hour. So I want to keep reminding us that when you do integrals, you're thinking in terms of area. And area is width times height. So anytime you're doing integrals, you're also multiplying your units together as well. So uppercase D of t is dominoes per hour. dt is hour. If I multiply dominoes per hour times hour, my hour will go away just in terms of dominoes. Right? If you accumulate your rate over a period of time, your units is not going to stay the same. It's going to change. So if you're ever having trouble trying to figure out what the unit is, just think, okay, integral is area. Take the 2 units that you have, multiply them together, and that's the unit that should result as part of that process. Okay, help session this afternoon, tomorrow morning, and Friday morning. I'll just pick problems and also just highlight the concepts that we're responsible for on the test. Okay. Encourage you guys to continue looking through the review worksheet. We're not going to get through everything, so the more time you can spend with those problems, the more prepared you'll be. Okay, see you guys tomorrow. Test Friday.